Dear students, now I am going to explain about the experiment number 5A, interfacing DC motor with Raspberry Pi using L293D. The components required for this experiment is Raspberry Pi version 3 model B is enough, and L293D dual motor controller. It is also called as motor driver, and DC motor which operates on 12 volt DC, and the maximum rotation speed is 60 rpm, and resistor for current limiting purpose and pull up purpose, and the power supply we can use batteries instead of using power supply, and connecting wires. These are the components required for this experiment. So this is the basic circuit diagram that how to operate this motor using L293D. Usually motor will consume more current. At the initial state, motor will consume 300 milliamps to 400 milliamps. During running state, motor will consume 150 milliamps to 200 milliamps. So the Raspberry Pi cannot provide that much of current to the motor. That is why between the motor and the Raspberry Pi, we are connecting L293D motor driver. It operates on H-bridge principle. So with the help of this L293D, we can connect two motors. So for example, here we have connected one motor. So the controlling pins for this motor is IN1, IN2 and EN1. IN1, IN2 stands for input 1 and input 2. EN1 is enable 1. So if this enable pin is high, then only this output will start working, okay, based on the input values. So IN1 and IN2, if IN1 input 1 and input 2 is 0 0, motor will not rotate. If the both the inputs are 1 also, motor will not rotate. If it is 0 1 or 1 0, the motor will run in forward direction or reverse direction. So if you want to operate this motor as per this input, this enable pin EN1 should be high. That is why we tried to this EN1 to plus 5 volt. So this is the operation diagram of L293D. So this is the IC L293D. This is the 16 pin IC, and which is having 4 ground pins, VCC 1 and VCC 2, and inputs, two number of inputs, two number of outputs for controlling one motor. Similarly, two number of input and two number of output pins for controlling another motor. So two enable pins are also available. This is the pin configuration, pin out of L293D. So as I explained earlier, this is the circuit operation. So here, for example, I have connected two motors. So here in this input, in place of this logic switches, we will connect the Raspberry Pi GPIO pins. So this is the block diagram of operation table of the L293D. Input 1 is high and input 2 is low. So output 1 is high, output 2 is low. Motor 1 rotates in clockwise direction. So input 3 and input 4 is high and low. Output 1 and output 2 is also high and low. Motor 2 rotates in clockwise direction. So similarly, input 1, input 2 is low. Input 3 and input 4 is also low. So output 1, output 2 is low and high. Motor 1 rotates anti-clockwise direction. Motor 2 is also rotates in anti-clockwise direction. Okay. So this is the interfacing diagram of uh, Raspberry Pi with motor driver and DC motor. This is L293D motor driver. This is DC motor which operates on 12 volt. This is the Raspberry Pi. Here we have connected a battery to provide the power supply to the L293D motor driver which operates on H-bridge principle. It's better to use separate power supply to avoid damages of Raspberry Pi. Okay, this is the connection diagram. As per the diagram, we have used GPIO 23 and 24 we have used to control the motor. Okay, so this is also a connection diagram. So as I said, GPIO 23 and GPIO 24 is connected to control the motor. So GPIO 25, these three pins are used to control the motor. GPIO 23 is connected to enable pin. It should always high to operate the motor in either clockwise direction or anti-clockwise direction. So based on the input from GPIO 24 and GPIO 25, this motor will rotate in clockwise direction or anti-clockwise direction. So now this is the connection diagram. Next, this is the program. So actually, first we will write the program in Python. So first you have to install the OS in the memory card and you have to insert the memory card in the Raspberry Pi. Those installation procedures are already given. So then you have to open the Raspberry Pi and in that you have to open the Tony Python IDE. In that Tony Python IDE, you can enter this program. First, you are importing the library rpi.gpio. So rpi.gpio you are importing and you will use this library as GPIO in the program. Inside the program, you no need to specify this complete name rpi.gpio. Instead of that, you can just use GPIO. That is why you are using import rpi.gpio as GPIO. Okay, rpi.gpio alias GPIO. Inside the program, we will use only GPIO and from time import sleep. So in this program we will use some delay, that is why you are importing the sleep function from the time library. And here you need three inputs. One is motor input 1, motor input 2 and enable. So you have connected those input pins to GPIO 23, 24 and 25. So you are initializing these three values for motor 1A, motor 1B, motor 1E. A, B are input, E stand for enable. So here first you are defining the setup function. What is meant by setup function? First you are set up the GPIOs. Okay, GPIO dot set mode. The Raspberry Pi you can set the Raspberry Pi mode as two modes. One is board mode, another one is BCM mode. If you are using board mode, you have to specify the pin numbers. If you are using BCM mode, you have to specify the GPIO numbers in the program. So here we are using BCM mode. We are operating our Raspberry Pi in BCM mode. So in program you should specify the GPIO numbering. And motor this GPIO pins you are initializing as a output pin. So motor 1A to GPIO 23, GPIO 24, GPIO 25. These three pins you are declaring as a output pins. So it should give the voltage to the L293D. That is why you have enabled these three pins as a output pin. So GPIO dot setup motor 1A is GPIO output pin. Motor 1B is also output pin. Motor 1E is also output pin. So this is the next one. You are defining the loop. So this is the loop. Inside this loop, first you are giving like this GPIO dot output motor 1A comma GPIO dot high. So motor 1A you have connected with pin number 24. You are making pin number 24 is high. Similarly, uh, 1B is connected to 23, you are making this 1B is low. So high and low means motor will rotate in forward direction. So if you want to rotate the motor in forward direction, motor 1A should be high, motor 1B should be low, and this enable pin is also should be high. Then only this motor will rotate in forward direction. And you are taking the delay for 5 seconds, and then next, you are making this 1A is low, 1B is high. Then it will the motor will start rotating in the anti-clockwise direction. So to rotate the motor in anti-clockwise direction, this enable pin is also should be high. After 5 seconds, it will run for 5 seconds. Okay, after 5 seconds, you are making this enable to low. So this motor will stop. Okay, this is the loop function you have defined, and again you are defining the destroy function. Destroy function means gpio dot cleanup. If you write this function gpio dot cleanup, immediately Raspberry Pi will make all the gpio pins, output pins, as a 0 volt. So that is gpio dot cleanup. Here your actual program is starting. If name equal to main, setup is here, define setup, this is the setup mode. And try loop, this is the loop function, it will execute except keyboard interrupt destroy. Okay, if any keyboard interrupt is there, immediately it will stop the execution. Other than this also, you can destroy the motor using the destroy function. So this is the program. You have to enter this program in Tony Python IDE, and you have to connect the Raspberry Pi motor driver and motor as per the circuit diagram to implement this experiment. So this is the procedure. First you have to identify the pin details of L293D motor driver, and you have to connect the motor IN1 to GPIO pin 24, IN2 to GPIO 23, and enable 1 to GPIO 25 as per the circuit diagram. Connect separate battery or power supply to the L293 motor driver IC to avoid overloading effect on the Raspberry Pi. So if you connect the same power supply with the Raspberry Pi as well as motor, it will create a overloading effect. That is why you have to avoid the overloading effect. You have to use separate power supply for Raspberry Pi and motor driver. That is why separate battery we have used in the circuit diagram. Okay. Usually the source voltage of the motor will be 5 volt to 13 volt. Here we have used 12 volt power supply, and enter the program in Raspberry Pi and observe the output. Okay. So these are the applications of interfacing the Raspberry Pi with motor driver. Line follower robot, you can use it for line follower robot, obstacle avoiding robot, quadcopter, or web control robot, like that. Okay. Thank you.